Okay, guys, this is section 8.3, objective number 3. I'm on page 15. So in this objective, we're going to use technology to compute and then interpret a confidence interval to estimate the mean of the difference for a population of paired data. So if you look at what I have in the blue box right here, this is our confidence interval equation, not unlike chapter 6, where we have a mean to estimate, but now it's mu sub d, the true mean difference in each of the pairs. And we do so by taking a point estimate, d bar, plus or minus a margin of error. So that margin of error, just like chapter 6, is t critical times the standard deviation of the square root of the sample size. But here in chapter 8, we're going to rely on technology to do this t interval. So let me tell you how we're going to interpret that and then show you a model problem. As in the last section, we are going to care if these confidence interval endpoints come out both positive, both negative, or negative then positive. So in the plus plus case, my interpretation would be that I'm 95% confident that the experimental treatment increases the response variable by blank to blank on average, and these two blanks would be the two confidence interval endpoints. And then the reason for the language experimental treatment and response variable is that many of these questions in this section describe an experiment that was carried out, so it makes sense that we're using the language of treatment and response. If we have two negative endpoints, we'd interpret that as a decrease from blank to blank on average. And if we have a negative and a positive, well, then we could have a decrease by a certain amount to an increase by a certain amount on average. Okay, so let's see the model problem. Scenario is a sleep disorder specialist wants to test whether herbal medicine increases the number of hours of sleep a patient gets during the night. To do so, the specialist randomly selects 14 patients and records the number of hours of sleep each gets with and without the new drug. Okay, so that with and without, each patient measured twice, that's your signal that this is paired data, and the parameter of interest is mu sub d, the true mean increase in sleep that the patients are going to get with this drug. Okay, so there's 14 patients. This is one table and then a continuation. It's not meant to be two separate tables. So these 14 patients need the matched pairs difference calculated out. So patient number 1, if we do with the medicine minus without the medicine, 2.9 and 1, that's a 1.9 difference. Okay, patient number 2, that's a 1.7 difference here, etc. Be careful because depending on the patient and the sleep, maybe the drug wasn't helping and there's a negative for the paired difference. Or maybe you got the same amount of sleep with and without the drug and there's 0 for the paired difference. Anyhow, calculate those 14 differences and then go put them into your stat editor list 1. So I have those previously typed in for us right here. Okay, so then what I'm going to do is stat test menu, option 8. Option 8 is the t interval. Okay, so once I click down to there, select it. Remember, you always have the choice to toggle of data or stats. We have data, so leave it there. List 1 is the default list where those differences are typed. Leave frequency on 1, confidence 0.95, and now let's calculate. Okay, so without having to use the equation that was in the blue box up here, the calculator did the work. It pops 2 endpoints onto the screen for me, right? And it gives us a point estimate as well. So on average, those patients were getting about a little less than half an hour, because 0.42 hours, maybe, I don't know, 25 or 26 minutes extra sleep on average, and that's what this confidence interval is going to estimate. So I'm going to take those 2 endpoints, round them to 2 places, makes sense. So 0.05 is the lower confidence limit and 0.79 is the upper one, and my sentence would go something like this, that we are 95% confident that the herbal medicine increases sleep by 0.05 to 0.79 hours on average. Okay, so just a couple of minutes to maybe just over 45 minutes is the average increase in sleep using this herbal medicine, and that was what the confidence interval t interval did help us get that estimate. All right, that's the end of 3 videos for section 8.3. You now have all the information you need to do homework number 2. Hope that helped.